I need you to have your calculator and yellow sheet. Okay, so there are going to be problems in this chapter where they ask you to solve for sample size. Specifically in this homework, but also, when the chapter reviews, they start to mix everything together. So when you have a problem that asks you to solve for n or solve for sample size, you want to look at this bit. But the piece I really need you to look at your yellow sheet for is I want you to make sense of this, where I got this from, off of your yellow sheet, because we're not memorizing right now, we're understanding, remember? So when I say margin of error, I don't care about the symbol here. I don't care about the inequality. Z star times standard error. I want that to make sense to you. So what I mean by that is look right here. Do you see how I have this bracket and it says margin of error? And I want you to know that the margin of error equals this times this. Let me say that again. I want you to know that the margin of error equals this times this. And strictly out of the book, it's got a less than or equal to formula in it, but we're not actually going to use that because I'm going to give you a life hack. So what I need you to know is that if it's a problem that's asking you to solve for n, I need you to think about margin of error equals critical value times standard error. So margin of error equals, again, don't worry about the inequality symbol. I'm going to give you a life hack for that. Critical value times standard error. So I want you to be able to find these things from your sheet and equal it to this because we're going to have an algebra problem to do. Okay, now next, if you're not given p hat, because they're trying to do this before a study was done, which is a good idea, right? You should probably figure out your sample size before you know what p hat is. That kind of makes sense if you think about it. Use 50-50 as a conservative estimate. So 50-50 is, you know, is a good bet to put in there if you're not given p hat. Okay, so now we're going to do algebra. In a company's prior survey, 80% of customers said they were satisfied. Find the sample size needed for a margin of error at least 3% with 95% confidence. Okay, so we're going to start with the life hack bit here. And the at least is this, the less than or equal to, but you don't need that. Like, don't confuse yourself with that. Let's just go with equals. You'll see why. Okay, so here's the formula I'm going to use, and I'm going to plug in right under here. So margin of error is 3%. So I'm going to put 0.03. So I'm plugging a number into the margin of error because it says a margin of error of at least 3%. Okay, now I'm going to take Mrs. Talbot's advice and not worry about the inequality symbol. I'm going to show you how to fix that in the end. Everybody good? Okay, then I'm going to fill in Z star based on my percent confidence. Does anybody have 95% memorized? Callie does. Anybody else? 1.96. Okay, so let's just put it over here. Is it important for you to memorize that? No. Do you know how to find it using inverse norm? Hopefully. Okay, in this problem, they give you a p hat of 80%. But remember, if they don't give you one, don't panic. You're just going to use 50-50 as a conservative estimate. 0.8, 1 minus 0.8, over n. Does everybody see where I put all of the parts? Okay, now we need to talk about order of operations. Okay, so first thing you want to do is divide both sides by 1.96. To make this look nicer, what I'm going to do is I'm going to say 0.03 divided by 1.96 equals. I'm not going to divide both sides by 1.96 just because it looks ugly. But I did, but I just didn't show it. Because I'm pretty sure everyone in the class is able to divide both sides by a number. Thinking we're all good. Okay, so I'm going to write 0.015. Are you guys good so far? Yes? Okay, now I'm going to do this bit. I'm going to do 0.8 times 1 minus 0.8. I don't really know why I did that on the calculator. It's clearly 0.8 times 0.2, which is 0.16. But it's fine because it's 8:46 in the morning on a Friday. And if we have to do it on our calculator, then we have to do it on our calculator. Now, if I was taking a stats test and I was you, I would do every single possible thing on the calculator because I would have zero trust for my mental math. Like even if it was like 3 times 2, I would be doing it. Anyway, okay. Now I have a square root. How do I undo a square root? Square. And I'm going to tell you something. This side is probably going to become scientific notation in your calculator every time. Don't freak out by it. That's just what happens in these. So 0. What I'm going to do is I'm going to take this big guy here from up there, the non-rounded version. So I'm going to put 2.343 times 10 to the negative 4. Then I'm going to multiply both sides by n to get rid of the denominator. If you want to, you can put times n times n. But does that make sense, everybody? The times n on both sides? Okay. And then divide both sides by the scientific notation. So what I do is, because I'm a lazy human being, I scroll up, I grab this, and then divided by, and then I scroll up and grab that. 682. No, I probably should have put the n on this. It doesn't matter. It doesn't matter. Okay, now I told you life hack, right? So you might be thinking to yourself, well, this is not good. It was an inequality, and I just ignored all of that, and I went to the equal side. Okay, and the reason that the inequality is there is because these numbers are discrete, which means that if you're taking a survey of people or measurement of things, it has to be a whole number. Okay, and you can't survey 682.95 people unless you're in the movie Onward, in which you could do 0.5 of that dad, I think, and that's just the pants walking around. But if that's not the situation that you're in, you don't have a guy that's just magical pants back from the dead, then you probably can't do this. So what you do is you just take whatever this is and round it up, because you need the next whole up to make that less than or equal to work. So you solve this like it's equals, even if you come out with 682.0000000000000001 0.67, you would still round it up to 683 because you're stating the minimum sample size that will work. And so you have to round it up to make sure that it meets that inequality. Okay, so even if you have 700 zeros, which you won't, even if your natural inclination is to round down, this one is very much telling you to round up. But what if you got 0.2? Round it up because it's a whole, it has to be a whole number and you have to make that inequality work. So that's my life hack. Ignore the inequality symbol and round up your answer. Okay, so we're going to write ourselves a little note. Okay, and then after that, this is the end of the notebook. In fifth period, on Wednesday after they did trash ball, I got the bright idea to use 0.67 as my p hat from trash ball, and it made me very happy. And I used p hat 0.67 through the whole problem, and it was great. Although there's no way I could make 67 out of 100 shots, unless maybe I was standing directly over the trash can. And even then, I feel like it would just bounce out. So I don't know. There were some really good trash ball players in this period. They were. Now, there was an argument about whether or not the trash can was too close. Oh, and then I made the mistake of leaving the trash cans by the tables for my third period, which was full of sophomore boys. Yeah. So there was inappropriate trash ball being played. Oh, they're very sweet though. They're just they're just, competitive, which is in my favor when they're competitive about math stuff. Okay, this is the last thing we're talking about before we move to the really, really poorly printed worksheet. And my life is like that. Like the coming to fix it today. If this lesson had been Monday, the worksheet would look pretty. If you thought it, you need to lower your verb. Okay, so this is a common sense question. And I have two ways to explain it. One for my common sense math, one for my common sense stats people, one for my math people. So there's two different explanations you could use for this. If the company wants 99% confidence instead of 95% confidence, will this require a larger or smaller sample size, assuming everything else remains the same? Explain your answer. Okay, so you want to be more confident. This is just it's almost a dumb question. If you want to be more confident, should you ask more people or less people? More people, right? Okay, so that's the common sense answer, which is totally fine for College Board. They don't care. Either one of these fine. These are fine. So, but we're going to say it in an intelligent way. Okay. Okay, that's the common sense response, which is 100% valid response. Okay, if you like that, you can sort of tune me out right now. But if you're a person who's mathematically minded, I want to talk about why this makes sense math-wise also. So I'm going to scroll up a tiny. Hopefully I can display it all. Oh gosh, this is not a tiny, I lied. Okay, which bit of my original problem has to do with the 95%? Z star, this guy. Okay, what would happen to Z star if I went from 95 to 99? And take a look back here if you want to at my poster. Look at the bottom two intervals. What would happen to my Z star, my number of jumps out, if I went from 95 to 99? It would get bigger, right? It would get somewhere around 2 to somewhere around 3. Do you see what I mean? Where there's somewhere around 2 to somewhere around 3? Okay, so it would get bigger. Okay, now that would mean this number is in the numerator. To balance that out, I would have to increase this number in the denominator. Okay, so mathematically speaking, to balance out the change in Z star, you would have to increase n because this is in the numerator and this is in the denominator. Okay, so those two sentences are saying the same thing. This is a common sense response. This is a mathematical response. Both are valid and completely 100% correct. It just depends on what you like better. However your brain works. Okay, it was 8:58. I'm going to give you 15 minutes to do your best job on this worksheet in your group, despite all of the horrible, horrible smudge on. How many times is she going to mention that? Several. Okay, you can use your notes, you can use your calculator, you can use your friends, you can use your. I think that's all I'm doing. Oh, yellow sheet would be good. I have everything but the teacher. I'm gonna put up the answers, so we can correct them together, but I want you to try to like reason all this out because we're working on this process. This is not from today. This is from the block today. So this is the FRP we learned on the block today. Just really trying to hammer it in there. Are you guys gonna see Jayla or Vanessa? Are either of you guys gonna see Jayla or Vanessa? Okay, that's fine. It's okay. So guys, I stole this from another textbook. I stole it. Or I don't know. The identify state conditions of the plan. Calculated do. It's just because I stole this from the CPM book. It's exactly the same thing. Take some. You wanted to do it one. Oh, okay. Let's look at the front page, please. I saw a bunch of really good stuff. I want you guys to all remember that we round differently, and that's okay. So your answer might not be exactly the same as mine. That doesn't mean you're wrong. It just means we rounded differently. It's okay. Just make sure yours is close. Okay. First thing I did was cross that out to make that state because it bugged me. P equals the true proportion of songs on the player that were loaded by Lori. Conditions I changed to plan. And I saw a lot of you guys forget to write the inference method. If I noticed one mistake, it was people forgetting to write the inference method. What? It's hopefully. Now I will accept either the fact that you said random selection or the fact that you said assume n equals 50 is a random sample of all the songs on the player. What I will not accept is the word random check mark or just a check mark. You actually have to say something from the problem. That's why we're doing it. Okay. N equals 50 is less than 10% of all songs on the player, which I identified as 2,384. And then large counts is 13 and 37. And if you did the formula to get the 13 and 37, that's totally fine. I was too lazy. Okay. I changed this to do. My statistic was 0.26. My standard error was 0.062. And my critical value was 1.645. I changed this word to error so that it would match that. 0.26 plus or minus 1.645 times 0.062. And I got to this. Again, make sure yours says around 16% to around 36%. It doesn't have to be exactly the same as me if you rounded differently through your process. Just make sure that it's, close-ish. And then I said we are 90% confident that the interval from blank to blank captures P equals the true proportion of songs on the player that were loaded by Lori. Okay, how did we do? Everything but the inference method? Yeah, that's what I didn't say state the inference method on the page. And I was like, they're not going to notice this little space I left for it, but that's okay. Okay, now the backside is 3 critical thinking questions. None of them are easy. Just take 5 minutes, do your best, and then we'll go over them. And if you need help, it's totally okay because it's Friday and it's critical thinking. You don't have to have the exact same thing, but I said, since the sample size n equals 50 is less than 10% of the population, 2,384, we can assume independence even though songs are possibly being selected without replacement. So if you just refer to the 10% condition or say it met the 10% condition or something like that, that's what you're trying to get at there. This is the recipe sentence. We take many random samples of size 50 and construct confidence intervals for each one. 90% capture, blah, blah, blah. Okay, and the last one is a normal CDF. And it says more than 18 of the first 50, so more than 18 over 50. So I did 18 over 50, which is 0.36. You can use the decimal if you want. Infinity, mean, standard deviation from the previous page. And I really wanted you guys to connect the fact that the mean is the middle, which is the point estimate of the interval. And the standard deviation and the standard error are basically the same thing. Yeah,